So hi everyone, in this session I'm going to rebuild the patcher that we built together in week 6 of the workshop series. Just to recap, that patcher was a sequencing and sampling system, and it built on some of the concepts that were delivered in the previous week's workshop where we made a looping patcher. So let's get started. First of all, if we're building a patch that requires audio to be stored and played back, what we need to do is to define some memory that allows us to store these audio samples. In computing jargon, this is known as a buffer, and in Max, the object is also called buffer. So tilde sign here means that it's designed to work with audio samples. If we press space, we can give this object 4 arguments, of which 1 is required, so we have to give this. So the first argument is the name, and this is defined as a symbol, which is like a word. The name is really important for a buffer because we need to know where the memory is in the computer so we can access it, and the name allows us to do that. So I'm going to call this samp1. This is going to store sample 1. The other arguments, file name, duration, and channels. So file name allows us to input automatically a file on our computer into the buffer. So if you've already got a pre-recorded sample, you might want to do that. Duration is how much memory we're allocating to this buffer, so how much memory it has. I'm going to put 2000 here because I don't think any samples I'm going to be working with are going to be longer than 2000 milliseconds, which is 2 seconds. And then we also have a channel argument. So if we were working with multi-channel systems like we did in the looping patcher, you could define how many channels you wanted. But because we're working with mono samples, we don't need to do that. Press enter, and now we have our buffer. If you lock your patcher and double click on the object, it will bring up the viewing window, and you can see on the time bar on the top it shows that this buffer's got 2000 milliseconds worth of memory, and when we record audio in, it will appear in here as the waveform like it does in Logic and Pro Tools. Okay, so let's click that off. So now we have the memory. What we need to do next is have a way to record into the memory. Now, if you remember back from the workshop, the object that we used to do that is called poke tilde. So if you type poke tilde and then look at the argument, so the first one is required and it's a symbol and it's the buffer object name. So this, we need to tell this object which buffer we want to record into. So in this case it's samp1. And then we can also define the channel number like we could with the buffer object, but because we're working in mono we don't need to do that. So press enter and we have our poke object. Now, if we hover over the inlets of our poke object, we have the first one, which says sample values to write. So this is basically the audio samples that are coming in from my microphone into the poke object that we want to be stored into our buffer. The second input is the index, the sample index. Now, if you remember back from the audio looping patch that we built, the sample index is basically telling the computer how to organize the samples that are coming in here. So we want sample 1 to be in sample slot 1, sample 2 to be in sample slot 2. So it basically allows us to organize the data coming in the right order, so in the time-based order. So first of all, let's work with this inlet. So we need to get some sample values in from our microphone. So let's press A on our keyboard, N on our keyboard. Type in ADC, analog digital converter, tilde, space 1, so channel 1, which is my internal microphone. The channels do differ from computer to computer and sound card to sound card, so you might need to make sure that you know which channel your microphone's on. Click off and we can connect that in. So now, if I turn on my audio and go to my buffer object, double click on my buffer object, you can see nothing's recording in, even though I've connected up my microphone into the poke object. But what you will notice is if I raise my voice, this little line here is jumping. And this is basically because we're sending in sample values, but we're not telling the poke object which sample slot to store the samples in. So it's storing them all in one slot at the beginning and not recording it over time. So that's the little kind of jumping bit that we can see there. So let's close down our sample window. Let's just stretch that out a bit. what we need to be able to do is send in a sample index, so something that's going to tell the poke object which sample slots within the memory to store these in. And again, there's an object that will do this for us, and it's called count tilde. So as you can see here, count samples elapsed. So what this does is it clocks to the sampling rate of your computer and counts the samples iteratively, so sample 1, 2, 3, 4, 5, 6. We press space to see what arguments we need to give it. So we have initial value, count limit, enable, and auto reset. None of them are mandatory, so none of them are required, but we actually do need to use all of them in this context. So first is the initial value. So we want it to start counting from 0. We want the count limit to be the maximum that we want it to count to, and this needs to conform to the duration of our buffer if we want to record into the entirety of the buffer object. So because this is in samples and I'm sampling at 44,100, the sample rate, the upper limit I need to type in here is 88,200. Okay, so it will count up to 88,200, which is 2 seconds worth of audio at my sampling rate, and then we want it to start again. Okay, so the enable argument basically means, though we want this object to start counting as soon as we turn on our audio, which we do, so we'll put a 1. And auto reset means once the counting object reaches this value here, do we want it to start again, which we do. So we want it to record on loop. So we press enter, plug that into our sample index inlet, and you'll be able to see now, if you double click on your buffer object, that we're recording into the buffer. Okay, but obviously this is recording on loop. And what we want to be able to do is, once we've recorded in whatever it is we want to sample, we want to stop it. Yeah, we want to be able to save it and stop it from recording over it. So basically we want to be able to pause the recording and start the recording. The easiest way to do that on Macs is to send in a sampling value, a sampling index value into this inlet that doesn't exist. So if we send in the sampling index value of -1, the buffer object doesn't have a -1 slot. It can't record samples into space it doesn't have, so that will pause the recording. So if we create a signal object, so sig tilde, and put the value -1, what this object will do is output a signal value of -1. Okay, so if we delete this one and plug this in, you'll see the recording is now paused and it's not recording. However, if I delete this cable and plug in the counting object, you can see I'm recording again. So what we need to be able to do is create an ability to select which one of these two objects is going to connect to this inlet. And Max has an object that allows us to do that, which is called selector tilde. We press space to see what arguments we need to give it, and see number of inputs is 2 because we have 1, 2, and initially open inlet. And what this basically means is when you boot up your patcher, which inlet do you want to be connected to the output? We don't have to worry about that because we're going to control which one we select with a toggle. Okay, so if we connect up the sig object to the middle inlet, which is input 1, the count object to input 2, which is the far right input, and now in this inlet, if we hover over it, it says we need to say which input we want to route to the output. Okay, so if we put a 1 in here, it will route input 1 to the output. If we put a 2 in, it will route input 2. So we're going to use a toggle to do that. Now if you remember correctly, a toggle outputs a 1 and a 0, and we need it to be a 1 and a 2. So we need to add 1 onto the toggle value and connect it up like so. And now when we turn our toggle on, we're recording into our buffer, and when we turn our toggle off, we're paused, we're not recording in. So we put a nice little comment box here saying record on/off. We know what that button does, that toggle does. Cool, so we've now created some memory that we can record audio into. So next, we need to be able to play the audio in the sample. Sorry, the audio in the buffer. Now, if you remember back to when we were building the looping patcher, we used the groove object to do that. However, in this case, we're going to use the play object. And the play object is designed for working with samples, so kind of single playback. Whereas the groove object is designed to loop and kind of do some more manipulation stuff within looping. So we're just going to use the play object, so play tilde, press space, 2 arguments, first one required, which is buffer name, so samp1, and then number of output channels. We're working with mono, which is the default, so we don't need to put anything in there. Press enter, and we have our play object. So let's hear what's in our buffer. So let's create an output, DAC tilde, arguments 1, 2 for outputs 1 and 2. Connect up our play object, create a toggle with a comment box for audio on, off. So we can turn our audio on and off here in our patcher. And now we need to create an ability to get play to play the information that's recorded in our buffer. So the play object is programmed to listen for the message start. And when it hears the message start, it will start the playback. So if we create a message object and type in start, connect that into the play object, lock our patcher and click it, and when we tap, we can hear our sample. Now, the play object's also designed to play back only a proportion of what's in the buffer, which is what we want because we want to record in a sample and then select just the proportion of the buffer that's got the sample in. Okay, so the way that works here is that the play object, when it hears the message start, it will look for 2 values afterwards, after the message. The first value it will use to play back, to define where the object starts to play back within the buffer. So if we put in 500, it would start 500 milliseconds into the buffer. And the second value will be the end of the sample, so where we want the buffer to stop. So if I typed in, if I typed in 500, 1000, what this would do is start the buffer at 500 milliseconds, start the playback 500 milliseconds into the buffer and stop it 1000 milliseconds into the buffer. Okay, so that's really useful because now we can record something in and we can select the start and end points of the sample within the buffer that we want it to play back. So we want to be able to change these values to fine-tune the sample playback. So I want you to create 2 integer boxes, comment box next to the first one which says sample start point, and then a second one that says start sample end point. So you should have 2 like this. Now we want this value to change this one here, and this value to change this one here. And this is all about, what we're going to do here is I'm going to show you how to format messages to make sure that you can send the right information in the right order to whatever object you need it going into. So because we're working with a list here, a list of information which has got 3 elements, we want to take these individual items here and put them into a list. Okay, so we want to join these together into a list of 2. And to do that, we can use a join object, which combines items into a list. Press space. You can see it has 1 argument, which is inlets, and it's required. So we want to have 2 inlets. Okay, we press enter. You can now see we have 2 inlets, input 0 and input 1. Connect up our start sample point to the first inlet and our start end point to the second. Let's create a message box and hook this into the cold input of our message box so we can see how it's working. So as I change this, you can see we've got the first value changing, If I change the second one, however, nothing's changing. But if I change this one again, it updates the second one. And the reason for that is that all Max objects that are working with data have what's called a hot and a cold input. The hot input initiates the object to do whatever it does. And value that comes into the cold input is stored until something arrives into this input. Okay, so what that means is we can't define the sample endpoint without redefining the sample start point. So the endpoint won't be updated until we change this one again. Okay. Now the join object has actually got a feature that allows us to circumvent that problem. So it will update on both of its inputs. And that's one of its attributes. So an attribute is a function of that object that you can change slightly. So you press at for attribute, and you can see it's got one attribute, which is trigger inputs. So the values we type after this as integers will be the inputs that will trigger a change in its output. So we want 0 and 1. So input 0 and input 1 will trigger an output. Press enter, and now if we change 1, oh, it's not working because I accidentally pressed enter there without putting the triggers in. So now you can see if you change 1, it will update the message regardless of which one you're changing. Cool. So now we have our values in a list. What we need to do next is prepend the word start to this list. So we can use the prepend object, space start. So we're going to prepend start to whatever comes into its input. Delete this cable here and hook this up. So you can now see that we have a list which is start and the first value and the second value. Cool. Now we have a list here which is stored in a message box ready to be triggered when we want the sample to play. So we can click it now, nothing's playing back. I move this to 0 and this to 1000 so we can 2000 so we can hear the whole buffer. And when we tap, you can hear that that's now working. Cool. So what we had to do with our looping patcher was create a way to view what was in our buffer. So when we change the sample start and end point, we can see what part of the buffer we're actually using as our sample, and this will help with us fine-tuning the system. And there's an object that allows us to do that, which is called waveform tilde. So we're going to use that one again. Okay, so waveform tilde, press enter, and it'll bring up this nice little black box. We need to tell this object using a message what buffer we want it to view. So message object M on your keyboard, type in set space and then the name of the buffer we want it to load up, connect that into its inlet, lock your patcher and click it, and it will load up the buffer. So now we can view our buffer, so we don't have to click on it anymore. Next, take your sample start point and press it, connect it up to the third input, and then the start and pull endpoint and connect it up to the fourth input. So now, when we change this, we will highlight a proportion of our waveform. So we can see what it is we're playing back within our buffer. Okay, and if I just want to play back this bit at the end here, make this shorter. Okay, so that's all working, and that's a nice way now for us to be able to play back some of our information that we stored in our buffer. So say if we've recorded in a clap, which I could do now, I can then highlight the clap, and that can be the sample that I'm going to play back. Awesome. So we have a way now to play our sample. So to record in our sample, we can play it back, defining the start and end points, so we can make sure the attack's right. Now we just need to have a sequencer grid, so we can sequencing patterns. Now the object we're going to use to do that is called matrix. Now the matrix object is a nice graphic user interface object that's used for several different things, but it basically allows us to lock our patcher and program in or activate cells within this kind of grid matrix structure. So that object, again, sorry if you missed it, was called matrix control. Press enter. Now we want, because we're making a sequencer grid, we probably want 16 steps, so each one of these is a step in a step sequencer. So let's go I on our keyboards to bring up the inspector, so Command I with the object highlighted. Go to the amount of columns, change that to 16, and we now have a grid of 16. We then can highlight parts of this which we want to trigger our sample. So this will be sample 1, this could be sample 2, this could be sample 3, this could be sample 4. So just like a normal conventional step sequencer where you have bass drum, snare drum, hi-hat or whatever. So at the moment we're just going to work with this one channel here, this one row, which is going to play back sample 1, and then we can duplicate up what we've done here, so we have sample 2, 3 and 4 as well. So we have this object here. What we want to be able to do is tell this object to output its contents. Okay, so we want to know what is in column 1, what is in column 2, what is in column 3, what's in column 4, what's in column 5. So we can use that information to trigger the respective sample if one of these is active. Now, what this object is programmed to do is to listen to the message get column. And when it hears the message get column, what it does is it takes the value after that message and outputs 1s and 0s to represent which of the items in that column are active and which are inactive. 0 for inactive, 1 for active. So if I create a message box and type in get column space 1, connect that into the input of the object, create a message box, connect that on the output here, you'll see that it outputs 0, 0, 1, 0. And that's because this is column 1. If I type in column 0, which is the first one, see that you get 1, 0, 0, 0, which matches the circles that I've activated within this matrix. So what we need to be able to do is have something that steps through each of these columns one by one at a given tempo. Now there's an object that manages time-based events for us, which is called Metro. So this one outputs a bang message at regular intervals. Okay, so at regular intervals it will output the bang message, which we can then use to step through each of these. So the Metro object, if you press space afterwards, has one argument, which is the interval. So that's basically the space between the bangs, so how quickly it's going. We can type that in there, but we probably want to be able to change it. So I'm going to create an integer box and hook that into the input here so I can change it with a number box. Create a toggle object so we can turn our Metro on and off. And now if you create a button object in your patcher by pressing B on your keyboard and hooking that up, turn on the Metro and type in, say, 500, you can see that that's now outputting a bang message every 500 milliseconds. If I type in 1000, it will output it every 1000 milliseconds, so once every second. Cool. So now we have a way to have a sequence of timed events. Okay. Now what we want to be able to do is send the message get column with 1, get column 1, sorry, get column 0, get column 1, get column 2, get column 3, 4, 5, 6 and so on. So we basically need to be able to count the bangs that are coming out of this up to 15 and then loop back around. And again, there's an object that does that for us and it's called counter. We press space as you can see from the description here, it says keep count based on bang messages, press space. We have one argument, which is options integer. Basically, we give it a 0 to start at 0, and then we tell it we want it to end at 15. So that's the range of the object. We connect up our metro, create a message box so we can see what's coming out of the counter. Turn on our metro object, and you can see it's now counting in time with the bang messages that are coming out of the metro. So all we need to do now is prepend the message get column to this, and then it will output each of these columns in time with the counter. So if we do prepend get column, hook up our counter object to the prepend object and hook that into the input, and then out of this output here you can see it's giving us a list of information which indicates which of these cells is active and which of these is inactive. But this is a list, and we want this to work as a individual value that's going to trigger this message here into our player object. So we need to unpack this. Okay, we need to unjoin these messages so they're individual. So if you remember here, we joined these two together. We need to do the opposite here so we can separate them to trigger individual samples. And the object we use to do that is unjoin. We have 4 elements in our list, so we type in 4, and then we have our outputs. Connect this up, connect up another message box to the first output, and you can see the outputting 0, 0, and it should go around if I do this and activate them all. You can see it's outputting 1 now because I've activated them all. Turn it off, outputting a 0. So now we just need that 1 when this is a 1 to play this. And then again, there's an object that does that for us. It's called select. Okay, and the select object listens for a message on its input, a message that's defined as its argument, and then outputs a bang when it hears it. So if we put select 1, when a 1 comes into this object, it will send an output as a bang message out of its first outlet. So here, if I hook that into here now, it's triggering the sample in time whenever this cell here is active. So if we turn this up, so we now can trigger the sample based on the matrix grid here. Cool. So now we've done that, let's work out how we can dupe all of this up so we can have extra samples, so we can have a sample for each one of these columns. And I'm just going to zoom out a bit here so I can add to the patcher without kind of having to scroll around everywhere so you can see everything. So what I'm going to do is actually delete this cable here and these 2 inputs here, and I'm going to take all of this, oops, sorry, delete this one and delete this one. I'm going to take all of this and I'm going to put it into another patcher, so within an object. So I'm going to go new object, P, and put samp1. That will bring up a new patching window for me. Highlight all of this, press Command C, double click into my patching object, Command V, create an inlet object. So inlet 1, new inlet 2, like so. An output, so an outlet object, outlet 1, and then another inlet. So then we have inlets 1, 2, and 3, and you'll notice these are always ordered according to where they're laid out from left to right within your patcher. So if we move that here, it becomes inlet 2. If I move it here, it becomes inlet 1. So now we have our playback mechanism within the patcher. Let's also take this here, Command C, lock your patcher, double click on the patcher here, Command V. Let's put that in here as well. Just keep this tidy. Have an inlet for our recording function here. And now we have everything that we need to record and access our buffer within a little patcher. And what that will enable us to do is first of all delete all of this apart from the record on and off, move that up here, connect up our start point to the second inlet, our end point to the third inlet, and our, oops, sorry, I think I've done that wrong. So if we go back here, we need our trigger to be inlet 2, start point and end point to be 3 and 4. So let's delete those two and start again. So we have our trigger in input 2, we have our start point input 3, endpoint input 4, and then record on and off input 1. Let's create a nice little gain slider, so new gain tilde, connect up the audio output into this one, and hook that into the DAC. And now we can control start and stop outside, and the start and end points of our sample outside of the patcher. If you turn this up, you'll be able to hear it working. Okay, and now instead of having to copy and paste all of that stuff individually out here, we can just highlight our patcher, Command C, Command V, call that sample 2, go in, change the buffer names because they all need individual buffer names to sample 2, to sample 2, to sample 2, create a new gain slider, hook that up, create a new waveform object, and new message, so sample 2 again, hook that up into here. All of this needs to be copied and pasted as well. So then we go, follow the same order, so record input output, trigger, so output 2 here because we're working in this with this dimension. And then we want loop start point and loop end point. And then we do it again. So copy, call it sample 3. Double click in, change it to buffer 3, poke 3, play 3, click off, create a new wave object, a new sample object. So call that one sample 3. Make sure you click these to make sure it sends that message to the waveform object. Highlight these ones here, and again copy. So first inlet, second inlet, third inlet, fourth inlet, gain slider, pick that up. Again, exactly the same way, and we're nearly there. So let's just move these down so we have a bit more space. And then finally, we want one more. So we need this one, sample 4. Change all of these so we make a new buffer, sample 4, sample 4, sample 4. And click this off. New gain slider into DAC. And then mimic again. So we need all of these. Go. So input 1, input 2, oops, make sure you connect them to the right one, input 3 and input 4, and then another waveform object. This one needs the message set samp 4 for buffer name samp 4. So it's clicked. So now we should be able to record into our buffers. Select start and end points for all of them, so let's do that. Oh, I forgot, you also need to connect these into the inputs of your waveform object so you can see what you're doing. So this is just duplicating what we did at the beginning, which is why I'm going quite fast. So now pop that one there, capture that part of the sound. This bit can capture that part of the sound. This one can capture this part of the sound. Turn all our volumes up. So let's slow that down a bit. So let's program something in. So let's record a sample in bass drum. Okay, so that's me doing a bass drum noise. Now the bass drum, let's do a snare noise. Ba, ba. Okay, we have a snare noise, hi-hat noise. Oops, I didn't mean to record over that. Ba. Ba. And then finally a cymbal noise. Okay, now let's program in a rhythm. So turned our metro on. Now let's start off with the bass drum. Bit of clipping there. Some hi-hats. Speed it up a little bit. So it's quite an effective patcher that's actually quite useful as a performance tool. I know that was quite a quick video, but play around with it and let me know if you have any questions.